Thank you, Stefan. Hopefully you guys can see me or hear me, and hopefully my screen is shared. You guys are seeing the screen, all right? Let me introduce myself a little bit. As Stefan had mentioned earlier, I'm Director of Compliance Certification for the OPC Foundation. I'm also a consultant. I work for a number of other companies too, and in my job as a consultant, I'm also editor for Part 2, the security spec, and I also do, let's just say, a lot of other work. Most of my work, or at least a big portion of it's funded through Yokogawa. So anyhow, let's get on and talk a little bit about IEC 62443 and about OPC security. So OPC-UA, as Joel had mentioned, is sort of designed to have security in mind. We know that in the OPC environment, you have many products from many different vendors, and these products have to communicate together and do it in a secure manner. So we have, client server and pub sub communications. We have information models that Jim and Wolfgang had talked about earlier today. All of this has to work together in a secure environment. When we talk about products, products could be on PCs, they could be on laptops or on rack-mounted servers. They can even be in embedded controllers or is built into devices. All of this has the same security requirements. So depending on the environment you deploy it in and in the device you're building it on. So there is a fair amount of challenges. I think for the talk, I'm going to focus just on the embedded device a little bit, but everything I'm saying applies to the whole range of devices. A device will have some application on it that you want to run. It'll be communicating to some client. And you want to be able to securely obtain that data, ensure that it's there, and you want to have the correct user identity and authorization information. OPC also has some global services that help with some of this too, certificate management, authentication, authorization sorts of services. And this talk really isn't about all of the OPC security items, but I do want to mention some of them pretty quickly. So we protect information. So as Joel said, the data can be encrypted so that you don't have any worry about someone eavesdropping on the data. You also can make sure that the data is always signed so no one can manipulate it. So you know that it's the right data that you're getting, that it hasn't been tinkered with. The other thing that OPC provides is a level of resilience to threats. So it's built in to handle all denial of service types attacks and maximizing availability. All of this was factored into the designs on OPC-UA when we built it. Another key point that Joel had talked about is the fact that we have application authentication. So we have certificates that identify who the applications are, and we can ensure that we trust the applications, that we only have communications between devices that are trusted. Beyond that, we also support user authentication. So this is identifying who is using that device. So who is sitting at the client's terminal and who is doing something to my controller or to my PLC. Key thing here is that there's different levels of access depending upon whether you are the administrator or a supervisor or just an operator. And you may have different parts of the plant that a particular operator has access to only. So all of this is supported through the authentication and authorization aspects of OPC-UA. We have role-based security built in so that the whole system can be handled via roles that are assigned to individual users that are logged in. So all of this are key concepts in OPC-UA. And of course, as Joel mentioned, auditability. We have the capability to support auditing of traffic and generating audit logs and recording what information is there. In OPC-UA, the auditing is handled through an event system so that you can centralize the storage of the auditing in one location, and the audit messages include client information and server-side information so that it's easier to link the various audit logs from different devices together. So if you are attacked, you can have a better way of diagnosing and looking at it. So this is all basic OPC functionality, but the talk really today is a little bit more about your general device, right? So in OPC UA, you have devices that very often have more things on them than just your OPC UA application. There are other third-party applications running on it. There may very well be certificate storage issues, which, by the way, I believe the presentation after me today will talk a little bit about TPMs and certificate storage and generally some standardized manners of handling that. You're going to have in a device, you may very well have other forms of communications that may not be secured, or at least not OPC UA communications. You may have other users that access the device through other interfaces. So when we're looking at security, you have to make sure you handle all of this. So not just the OPC UA end, but the entire system. And that's where the IEC 62443 standard came into play. This was a standard that was developed by ISA and IEC in a joint set of working groups. It isn't a standard, it is actually a whole set of standards. It provides a set of common terms and ways of describing security, which is always important so that everybody's looking at it from the same point of view. It has standard policies and procedures for how to implement security. And this standard isn't just about current running systems, it's about the life cycle of the model. So it's from patch management and deployment through decommissioning, and it has the entire life cycle of security. I'm not going to spend a long time talking about ISA 62443. There's a lot of other online videos and a lot of presentations that you can look at that provide a lot of detail on this. But the key points are that it does have multiple facets to it. It talks about system level things, so how to configure your system so that it has the right zones and conduits and that it has the right security levels from a system point of view. It also describes how you should be developing products to make sure that they're secure. What we're going to talk about mostly today is this last spec, which is the requirements for building a device and how to make sure that what you built is secure. So that's just one little piece of the 62443. So let's go on a little bit. One of the things that's mentioned in that spec is security levels, all right? Assurance levels, I should say. And this has to do with what sort of attacks you're trying to build your device to handle. There's 4 main levels, and I'll let you guys read these at your own leisure, but the key thing is that the security levels change quite a bit as to what sort of attackers you want to be able to have to deal with. What we're talking about today is mostly SL2. That's the sort of type of security features that we're discussing at this point in time. SL4 is, some infrastructures need that level, but typically most plants survive with SL2 or SL3. But anyhow, we'll continue a little bit more. I mentioned all the features that OPC UA has built in for security. So, I'm editor of the security model, which is in part 2, but security is spread out through our specifications since it's built in. So services describe security. There's mappings to different communications protocols that have security features. There's, of course, profiles that describe what functionality you have. There's a specification on discovery and how you handle discovery. That has security pieces. There's the pub-sub communications model. That also has security built in. We have role-based security, so its own specification for the information models that are related to assigning and managing role-based security. There's a new specification on device provisioning. So all of these specifications have security-related information. So what did we do? In OPC Part 2, we provide sort of an overview of the types of attacks and types of data that OPC handles. And we added an annex into Part 2 that describes a mapping for the 62443-4-2 and about whether the different functionality that's described in that specification applies to OPC to start with, but also where you would find the details on how to handle what is being required in 62443. So you'll see that we have basically a table that describes what part, OPC Part 4 or Part 6, that would have features related to user identification and authentication. And the further it puts in some keywords, so some tokens that you can use when you go look for the specification. You can go search for issued identity token, and in Part 4 it'll give you a section or a set of text that describes exactly what issued identity tokens and how they're handled. So it basically is generating a cross-reference. For the Part 7 references, since Part 7 is really our profiles and conformance units, here the normative section isn't a spec, but it's an online database. So what gets listed in the tables is a set of conformance units and or facets that if you went and searched in the online profile tool, you would find the items that are relevant to that particular topic. So when you're building a system and you want to make sure it's 62443 compliant, you would be using the information that's in this annex to help you make sure you've mapped and you've generated everything you need to be compliant. We also describe things that don't apply. So there are sections that currently don't apply to OPC specs. Remember, the ISA 62443 is a life cycle model. So there are pieces that you don't get from OPC UA. There's things you have to build into your system. They're not standardized by the OPC Foundation. So let's talk a little bit more about the mapping. So Part 2 describes the 4-2 mapping. There are other pieces there, system level items, and in the future we'll work on some of those. And oh, by the way, I should have credited this even earlier. This mapping, this table that we have, it was generated actually by the Open Group in their OPAS standard version 2.1. They allowed us to publish it. We reformatted it a little bit to fit the OPC Foundation document templates and formats, but it was originally generated by them. This day and age, a lot of these groups work together closely, so we work a lot with the Open Group and their OPAS standard. But the key point is that this is a mapping, and in future we'll publish additional mappings for additional specs and additional pieces as we need to. We're going to keep working on making this easier for our vendors for when they do it. So if you want to work on 62443 compliance, what's the first thing you want to do? You of course want to get your product certified by the OPC Foundation. Note, I'm director of certification, so I have to get a plug-in for certification. But we will test security and make sure that your product at least passes all the OPC required security items. But once you've finished our certification, you should look at ISA Secure. So this is a organization set up by through ISA and through the joint effort, and it provides certification for 62443 and provides the life cycle sort of certification. This is sort of an important feature. Some groups are starting to require this. The Open Group requires this for their products that they actually become ISA secure. This is, mind you, the organization that handles certification of 62443. There are a number of test labs, not just the ISA ones. There's the TUV, I think, TUD in Europe. So there's multiple organizations that actually do the testing. They're just all managed through the Compliance Institute, if I understand this correctly. So that's what I have for a sort of quick presentation on 62443. I welcome having questions. Please enter them into the question and answer session, and we'll try to address all your questions. Thank you, everybody.